Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. So we want to find the work for an expanding spherical ammonia bubble. Okay, so the bubble expands from 2 centimeters to 4 centimeters. We've got the surface tension of 0.02 Newton per meter, and we want to find the work in kilojoules. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. So we got a sphere expanding to 4 centimeters. Step 2, list all the given variables and find the unknown. So all the same values that I just mentioned before. Step 3, find the formula for work with respect to the expanding bubble. In this case, it's a sphere. So we're going to have to integrate because it's a sphere and it's expanding. So once you've done your integration, it will come out to be this formula. So that's what you derive it from. So you use this formula and derive it to this. Okay, I am going to assume you've done calculus. Alright, so step 4, plug and play. For those that haven't done calculus, the surface tension is brought out because it's a constant. We've got the limits of the final minus the initial, and dA is the change in area. So that's where the A2, which is the final area, minus the A1, which is the initial area. And what they do is then they factor out the area, since it is a sphere, and they simplified it to 4 pi multiplied by the radius squared of the final minus the initial. Okay. So we just plug and play. So sigma is the surface tension. That's the symbol, the Greek symbol for surface tension. In this case, sigma can be different things. Okay, so surface tension multiplied by 4 pi multiplied by the change in radius. Make sure you square them both. So we've got 0.020 meters. That is 4 centimeters divided by 2, because that's the radius. So the diameter is 4 centimeters. So the radius, of course, is 2. And the same for 2 centimeters. That is 1 centimeter. But we want it in meters, so we can match the units and cancel them out. Alright, that will give us 7.5 times 10 to the power of minus 5. Or, in long form, 0.000075 Newton meters. And then you multiply by your conversion factor to get it into kilojoules. So 1 kilojoule is 1 per 1,000 Newton meters. So that will give us 7.5 times 10 to the minus 8 kilojoules for the work of the expanding bubble of the ammonia. Alright, thanks for watching. Disclaimers: the method is correct, however I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things just happen. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. So click on your taskbar icon for the snipping tool. If it's not in your taskbar, then go to your Windows search, type in snipping tool, open the program. Once it's open, click on video option, click on new, left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish, hit the red square in snipping tool to stop recording, save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made-up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in this video, leave it in the comment section. I will get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.